Welcome everybody who's already here. We're just going to wait 1 minute for folks to get their audio linked up and be ready to roll here. All right. Well, welcome to the first lecture in the 2022 Innovation in the Berkshires lecture series. And I forgot to spotlight my video. Let's do that. Here we go. My name is Carol Allman Morton, and I am the Executive Director of the Osher Lifelong Learning Institute at Berkshire Community College. OLLI at BCC is a volunteer-driven program that is a non-credit learning community for adults 50 years old and better, including courses, special interest groups, lectures, and events in person and online. You can learn more at our website, which is berkshireolli.org, which I'm going to pop in the chat right now. In 2019, OLLI at BCC initiated a collaborative partnership with One Berkshire and the Berkshire Innovation Center, resulting in multiple lecture series to advance regional understanding and readiness in the field of emergent tech. We are so glad to be part of this initiative, which melds together key OLLI goals to learn and to contribute meaningfully to our community. You can learn more about our partner organizations, One Berkshire and the Berkshire Innovation Center, on their websites, which I will also pop into the chat. Tonight's session is recorded and will be posted on the OLLI YouTube page in case you miss anything, or if you'd like to share the link with a friend. And I'm going to put that link in the chat. It's all links tonight, just for now. All right. This series will continue Wednesdays through November 16th, and you're welcome to attend any and all of the lectures. And right now I'm going to turn things over to Ben Sosny, Executive Director of the Berkshire Innovation Center, to introduce tonight's speaker.
Thank you very much, Carol, and thank you everyone for joining us. The Berkshire Innovation Center serves as a catalyst to spark innovation and sustainable growth of technology-focused companies here in the Berkshires. We do this through programs that promote learning and enrich people in technology led career paths and providing research and innovation space for people and companies exploring new technologies and growing their businesses. We're also very focused on convening a community of like-minded people here in the Berkshires, and I am thrilled to be participating in this lecture series in collaboration with OLLI and One Berkshire, and I think leadership, those organizations that make this possible. Early on at the BIC, I met our friend Evan Hickok, who has been at General Dynamics in Pittsfield for a number of years. Evan immediately gravitated towards the BIC because of his collaborative nature and his passion for innovation, but also in education. And Evan played a key role as we launched a program for high school students called the Beta program, and has continued to engage anyway, whether it's through robotics challenges or introducing us to young engineers at General Dynamics. I also had the opportunity to listen as Evan gave a talk on the history of innovation in the Berkshires to incoming employees, new hires at General Dynamics. I think this is such a critical point. You know, when we opened the Berkshire Innovation Center in February 2020, something we really wanted to drive home was that innovation certainly in the Berkshires certainly did not start in February of 2020. The idea to put an innovation center here was not sort of to force something. Innovation is really in our DNA, and it dates back very far. And I think as we explore new opportunities for companies in key sectors and where the Berkshires fit in, it's important that we ground ourselves first and talk about this past and this really rich history. So I reached out to Evan to do this. Evan is doing a stint in the UK right now with his family for General Dynamics. So he's joining us from abroad, and it's late there. And Evan, I really thank you for your time and for all you do for the Berkshires. So Evan Hickok.
Well, Ben, thank you for that gracious opening, and thank you for all that you do at the BIC. I think the BIC is a very exciting place. And I feel honored to have had an opportunity to collaborate there since we opened. And thank you, Carol, for this introduction to OLLI. OLLI is such an incredible an important institution in the Berkshires, and I'm very honored to be here to help tell this story.
Well, thanks, Evan. I encourage our viewers to share their questions, start accumulating them in chat. We're very lucky to have Catherine Kidd, who I've partnered with for a long time on this project. And Kate will be monitoring, and we'll be following up with questions to Evan after his presentation. So thanks, Evan. Thanks, Catherine.
Yeah, cheers. Yeah, forward to your questions. I think I've given this talk or in some form almost 20 times, and I learn something every time I do it. So as Ben mentioned, I give this to our new hires. Every engineer that we hire in Pittsfield since January 2020 has heard this. So part of what we're describing here, you see this title page here. It's called the General Dynamics Mission Systems Pittsfield Origin Story, but it's also a brief history of technology of the Berkshires. I first started thinking about this, I think it was in 2010. We delivered a ship called LCS-2, the Littoral Combat Ship 2. And the first commanding officer of that ship, his name is Captain Michael Riley. He came to visit us in Pittsfield after he had accepted delivery of that ship. And he was incredibly impressed with the ship, and he wanted to say thanks. And so we had an all hands, or about 1,000 engineers gathered together. Well, I should say engineers and program managers and manufacturing professionals and finance and human resources. We had an all hands. And in that all hands, he remarked how cool it is we get to do this work here in the Berkshires. He described that most of this defense work is done in areas with a lot of traffic, like Orlando, Florida, or Washington, D.C., or the Virginia Beltway. We get to do it in an area that has fresh air. And I thought about that for a long time. His question really sat in my mind. When I finally started looking in this, I found a pretty compelling story. I think I sat on it for a decade or so. This took me about 2 years to pull together. Anyhow, here's what I found. So this is a story of General Dynamics in a way, right? It's the General Dynamics Pittsfield campus told through the lens of world events. Anyhow, let's get into it. Just a little bit about me here. I went to UMass Amherst. I graduated 2003 in mechanical engineering. I fell in love with Western Mass there, and I thought I'd stay. And I found a great opportunity at General Dynamics over 19 years ago. Had a number of roles here, and I'm doing the same work in England, representing General Dynamics on these same programs, which I think is incredible. I've also been to Australia out of this little work that we do in this little business. I have 2 daughters. They're 6 and 3. I'm a cyclist. The Berkshire's great place to be a cyclist for sure. I'm an avid reader and a woodworker. Okay, let's get into the timeline here. So it all starts in 1886. This is William Stanley. And William Stanley perfects the power transformer in Great Barrington, Massachusetts. And he starts a business. And that business is called the William Stanley Manufacturing Company. And it starts a high density of engineering and manufacturing talent in Pittsfield. So in 1940, Pittsfield's got this rare density of engineering and manufacturing talent. And that talent was asked to turn to the World War II effort. To make this is the Mark 37 gun director, which we'll talk about. And so the buildings that you'll see just a mile from the Berkshire Innovation Center, those were built in 1940 to support World War II. So then we'll talk about the Cold War. This is the E-2 spy plane. The E-2 spy plane was not designed here. It's designed in California by Lockheed Martin. But in 1956, the E-2 spy plane flew over the Soviet Union and showed that there was no bomber gap. We thought there was a nuclear bomber gap, and the E-2 spy plane proved that there was not. And the nation should actually invest in the Polaris, a submarine launched ballistic missile, which has been on continuous deployment since 1960. And we have been working on this in Pittsfield since 1957. So then we'll talk a bit about how the events of 9/11 and some other events around there, and how we were responding to that. And the way we were responding to that, we're actually transforming the face of the Navy. This here is an Ohio-class submarine that has been backfit with, it was originally built to launch the submarine launched ballistic missile, but it was transformed to actually launch Tomahawk cruise missiles to face the asymmetric threat that we see in 9/11 and other threats like that. And this is the littoral combat ship. So I'll talk a bit about how we're transforming the face of the Navy. This looks a lot different than the Navy did looked before the 2000s. We'll talk about just briefly about how the success that we've had has manifested itself in continued investment from our customers. We've had expansions in 2006, major expansions in 2008. You saw in the paper, I'm sure, expansions we had in 2020 across the street in One Plastics. And we've actually got a program that goes out to the year 2084. The submarine that I'm here in England to help build will be in the water till 2084. The US will have submarines at 2084. So this is actually describing an almost 200-year arc. Okay, let's get into it. So as I said, William Stanley in 1886 perfects the power transformer. Stanley was working for the Westinghouse Electric Company in Pittsburgh, but the smoke of the city was causing him health problems. So he moved to Great Barrington, where he had family. He went there to get some fresh air, really. He was one of the earliest telecommuters. We saw a lot of that happen in COVID too. We saw a lot of people come to the fresh air. They found that they could work remotely. This is Stanley's original transformer. I believe that this lives at the Berkshire Museum. So his big innovation here, previous transformers had their coils wired in series, but Stanley wired his coils in parallel, which made them self-regulating. So when a new load were introduced, like when another light was turned on, the other loads downstream were unaffected, which was a big deal. It's what made the technology really work. So he demonstrated this by lighting 7 offices, 2 hotels, and 13 stores on Main Street in Great Barrington. And you can read the power cables were strung along the elm trees along the side of the road. Of course, it wasn't much electricity in the city at the time, and wasn't much electricity in the world at the time. And a lot of what was around was direct current. So this innovation brought alternating current to the forefront, and the transformer allowed us to transmit power over long distances at high voltage and low loss. This is still the basis of the power grid we have today. So here's an image of the Stanley Manufacturing Company from 1903. The Berkshire Innovation Center is right here. It's right in these grounds, and this is the bridge that goes over the train tracks just outside of Ben's office. So Stanley founds the Stanley Manufacturing Company in Pittsfield. They had 16 employees in 1890, but in 1903, just 13 years later, 1,200 employees. Just a staggering amount of growth. Here's a shot from 1910. I like this caption here. Pittsfield is the city that electrifies the world, and I think that this picture illustrates that. You can see. I'm always struck by the size of some of these things. There is a human. Here's a human right here. I've given this talk almost 20 times. I always have a hard time finding him. Here's a couple others. Some of these transformers are very small. Some are incredibly large. The diversity is huge. This technology is, just about 20 years old at this point. Here's another glimpse in 1912 from a postcard that says 6,000 people are employed. At this point, this is owned by the General Electric Company, who bought William Stanley's company in 1903. 6,000 people in a 20-year-old company. Here's one of the largest transformers in the world, 1919, another huge record-setting transformer in 1926. This is in 1954. I believe that this gentleman here is on the 10th step of this ladder, so this must be, close to 25 feet tall, just absolutely massive. We also built a lot of very important transformers. I'm sure many of you have been to the Hoover Dam. This is a picture of the Hoover Dam here. So when the Hoover Dam was built, it was the largest construction site in the world, and they had to build the world's largest concrete factory on that construction site. And when they needed their transformers, they came to Pittsfield. In 1934, we delivered the Hoover Dam transformers. When the country was racing against the Nazis for a nuclear bomb with the Manhattan Project came to Pittsfield for their transformers. And when the country was ramping up for World War II, we needed aluminum to build bomber airplanes. And Alcoa was creating a new aluminum plant on Long Island, and they came to Pittsfield for their transformers. Now, this is interesting. When in World War II, copper was actually in short supply, and you use copper for the windings on the transformers. So they actually borrowed silver from the U.S. Treasury for those windings, which were recovered like something like 5 years later. There were guards from the U.S. Treasury, armed guards from the U.S. Treasury, making sure not an ounce of silver vanished. It's just how important this technology was. I find that very stunning. Okay, let's move into 1940. We're going to talk about World War II, and we're going to talk about the nuclear age. So 1939, of course, was a very important year. This is a photo of Leo Szilard and Albert Einstein on Einstein's porch in Long Island. So by 1939, the atom had been split in many parts of the world. It had been split in France, in Belgium, the United States, and in Nazi Germany. So Leo Szilard believed that the energy released by fission could be used to create an atomic bomb. There were German nuclear physicists who had written papers in 1939 about the exploitation of nuclear energy. Now, Szilard himself had fled to the United States from Hungary in 1938 to escape Nazi and fascist repression. And he and fellow Hungarian refugee physicists like Edward Teller and Eugene Wigner were quite weary of Hitler. They believed that if he were successful in developing a nuclear bomb, he was also likely to use it. So they felt it was their duty to alert the United States. But nobody knew who they were. So Szilard and Wigner drove to visit Albert Einstein to catch him up on these developments. Einstein was largely retired at this time, and he told Szilard that he had not thought about the possibility of a nuclear bomb before. Now, this is Einstein, right? E equals mc squared is the equation that actually describes the relationship between matter and energy, but he had never considered the possibility of a nuclear bomb before. So together they wrote a letter to the president, Franklin Delano Roosevelt, describing the possibility of a bomb, that the US research to date was being carried out within the limits of the budgets of university laboratories, and to warn the president that Germany, who had invaded Czechoslovakia the year before, was known to have stopped selling uranium from the mines they took over there. And they believed that that was a sign that the Nazis were working on a bomb. So you can see this letter, you can find it online. It was sent on August 2nd, 1939. Of course, on September 1st, 1939, less than a month later, Hitler invaded Poland and World War II begins. About a month later, in October, FDR writes back to Einstein and says, "I heard you," and the Manhattan Project was started soon after to beat the Nazis to the bomb. So by 1940, the war was already incredibly bleak. Nazi Germany had largely taken over Europe and was using its resources using the resources of Europe against the Allies. Really, only Great Britain was left, where I am today, and they were being bombed brutally. Now, in 1940, the military of the United States was only 20,000 soldiers strong. It was smaller than the Army of Belgium. The United States was still reeling from World War I, where 10 million humans had died, and the country was incredibly reluctant to go to war. So FDR delivered this speech known as the Arsenal of Democracy on December 29, 1940. In it, he urges the industrial capability of the nation, the engineers, the manufacturers, to start making material for the war. Now, this is obviously a very long speech. I'm going to play 2 minutes of it, which starts about half an hour in. Now, this is the call to action, which Pittsfield answered, and we are still answering today. Pardon me. There it goes.
9 days ago, I announced the setting up of a more effective organization to direct our gigantic efforts to increase the production of munitions. The appropriation of vast sums of money and a well-coordinated executive direction of our defense efforts are not in themselves enough. Guns, planes, ships, and many other things have to be built in the factories and the arsenals of America. They have to be produced by workers and managers and engineers with the aid of machines, which in turn have to be built by hundreds of thousands of workers throughout the land. In this great work, there has been splendid cooperation between the government and industry and labor, and I am very thankful American industrial genius, unmatched throughout all the world in the solution of production problems, has been called upon to bring its resources and its talents into action. Manufacturers of watches, of farm implements, of linotypes and cash registers, and automobiles and sewing machines and lawn mowers and locomotives are now making fuses and bomb-packing crates and telescope mounts and shells and pistols and tanks. But all of our present efforts are not enough. We must have more ships, more guns, more planes, more of everything. And this can be accomplished only if we discard the notion of business as usual. This job cannot be done merely by superimposing on the existing productive facilities the added requirements of the nation for defense. Our defense efforts must not be blocked by those who fear the future consequences of surplus plant capacity. The possible consequences of failure of our defense efforts now are much more to be feared.
Pretty powerful words there. One of the things he describes is that, we can't be worried about having excess manufacturing capability or capacity. And that's actually, we were actually funded by the Navy. I think it's in the Appropriations Act of 1941, but the money arrived before the Appropriations Act. That actually built the buildings that you see today on Plastics Avenue, called OP1 and OP2. This is an incredibly difficult call to answer, but the nation did. There were cities with lots of engineers and manufacturing capability that turned to. In Detroit, Ford and General Motors made airplanes. Ford made a bomber every single day in 1945. The Singer Sewing Machine Company made parts for the Sperry T-1 bomb site. And of course, Pittsfield answered the call. So OP-1 was built to make the Mark 37 gun director. This is a fire control system for battleships and destroyers of the new Navy. If you went to Battleship Cove in Fall River, Massachusetts, you could see a Mark 37 gun director on the USS Massachusetts there. So this gun director controls a 5-inch gun and a 36-inch searchlight. It took 5 men to man this. And there were 3 who sat in front side by side. There were 2 in the back. And so a lot of the guns, there were a lot of gun aiming systems back before radar. There were ladder sights. There were ocular ones where you could you'd have, or binocular ones where you'd have two lenses that you would look through, and you turn this dial until the 2 images kind of merge and become one image, and that would be used to calculate range. Range is incredibly important in it's the main input to a ballistic algorithm. But radar really changed everything. Radar came out of MIT. It was invented right around 1940. I don't remember the year, but we were one of the first builders of radar and a fire control gun system here. That's what we worked on. Now, the first gun director was delivered in April of 1942, and it was mounted aboard a destroyer called the USS Fletcher. And from what I've read, the Fletcher had a brilliant career, and the 37 gun director served her very well. She sank many enemy ships and splashed several enemy aircraft. OP-2 was built to make 5,000 horsepower motors and later torpedoes. And then there's also OP-3, which is down Merrill Road, kind of towards Dick's Sporting Goods. OP-3 was built in 1949 to make the Mark 56 gun fire control system, and now it works on guidance systems. Okay, so now let's talk about the Cold War. We'll talk about the nation's response to the Cold War, including the development of the Polaris program. This first capability, initial capability that was created in 1960 is the one that has the program plan until 2084. It's the one I'm supporting here in England. So obviously 1945 was a very fateful year. We were successful in beating the Nazis to the bomb, first with the Trinity test on July 16th, 1945, the first detonation of atomic bomb. Then Hiroshima and Nagasaki, and World War II ended. But there wasn't peace for long. There were several spies from Los Alamos who brought nuclear technology to the Soviets, and the Soviets tested a bomb in 1949, and that was the beginning of the Cold War. So we'll talk a little bit about the Cold War. Cold War was a nuclear arms race, of course. The US and the Soviets were both very secretive of what they were developing and suspicious of what the other side had. And the fear of mutually assured destruction was very high. So I'll talk just briefly about nuclear deterrence here. This is the nation's response. Deterrence is a strategy intended to dissuade an adversary from taking an action not yet started, right? This is war here. I'll use a violent analogy. This is like having that big buddy of yours who comes to the bar with you. So nobody would mess with you, right? This is a counter strike that's so strong that nobody would ever strike first. So obviously during the Cold War, the United States and the Soviet Union were each building up a stockpile of nuclear weapons, and it was deterrence that the United States adopted. This is a credible threat of retaliation, and this is at work today. I think Ukraine would look. Well, there's been a lot of talk in the last couple of weeks. Putin has been rattling his nuclear sword, and it is really the deterrence is working if he has not yet used anything, and I don't think he will. But at one point, there were 80,000 nuclear weapons in the world, including shoulder-fired variants. By the 1960s, there were three deterrence systems emerged as a basis of strategic deterrence. They're now known as the Nuclear Triad. And I'll just show that here. So this is the Nuclear Triad. There's the sea leg, the land leg, and the air leg. So the sea leg are these Ohio-class submarines which launched the Trident II D5 missile. The land leg is the Minuteman III. These are the proverbial 450 missile silos in the cornfields in Middle America. And then there's the air leg, which is the B-2 and the B-52. So we're going to spend most of my time here talking about the sea leg. The land leg was, the air leg was the first that was established. There were 3 B-52s delivered in 1952. And 5 years later, we go from 3 B-52s to 181 in 1957. It's just a very scary ramp up, really. It's incredibly flexible, it's incredibly versatile, and it's also very visible. Visibility, sometimes you want visibility. I think, let's see, when you want to deter somebody, you show them the stick. When you want to defeat somebody, you don't show them the stick. With visibility, obviously comes consequences. We know that, I'm sure you know that a U-2 spy plane was shot down in 1960, and that really got us thinking about the air leg there. The land leg was the third that was established. This first entered the Strategic Air Command's arsenal in 1962. But we're going to spend some time talking about the land leg here. We've been working on the land leg in Pittsfield. The sea leg. We've been working on the sea leg in Pittsfield since 1957. And I believe that this is the leg that ended the Cold War. So I'm going to show the Cold War on a single slide here, if I can. So this is obviously showing the years from 1960 to 2020. On the y-axis, here show the number of ballistic nuclear submarines that are in the fleet. So it shows here there's one in 1960. There's 40. What was this number? I think 41 in 1965. So that's just an incredible ramp up, right? We went from 3 B-52s in 1952 to 181 in 1957. And now this incredible ramp up of submarines. Very, very scary time. And then you can see this go down here, right? So what's going on here? The Berlin Wall here, right? 1960 to 1989, 1990. You can see it's all concurrent. Cuban Missile Crisis in 1962. The space race, Vietnam, USSR invades Czechoslovakia and Afghanistan. We're still fighting this today. And then, of course, the Soviet Union collapse. I hope we don't see a buildup over here, but this is certainly a scary time. When I started, almost 20 years ago, the thing that I would hear from a lot of the engineers, they were fairly certain that that this was the weapon that ended the Cold War. The Cold War, well, really, the Soviet Union collapse was both political but also economic. They tried to spend themselves. They tried to beat us with money, and they collapsed their economy. And I'm going to talk a little bit about how we made a decision to focus energy and engineering into another direction. I think that was a key decision here. So let's talk about that here. So Moscow held an air show in 1955, and they released footage of the Tu-95 Bison bomber. This is a nuclear bomber capable of reaching the United States, the first time we were truly aware of this capability. So there appeared to be an endless stream of Bison bombers in the sky at this 1955 air show. So we thought that there was a huge bomber gap. And so we doubled the production of B-52s, which I've shown in the previous slides. Now, we didn't really know how many they had. So the spoiler here is that the Soviets are actually flying the same few planes in a circle. The gap wasn't that large. So the US was actually investing in the wrong area in bombers. Then we learned that we needed to stop investing in bombers and invest in the submarine launched ballistic missile. So what I'm trying to establish here is that part of the Soviet Union's collapse was economic because they were spending in the wrong areas. But we learned to spend in the right area. I'm just going to show a couple minutes of this video. I think about 4 minutes of this video here.
Summer of 1955, the major powers convened in Geneva. The Russian delegation was led by Marshal Bulganin and Nikita Khrushchev. Eisenhower's most striking proposal was open skies. Ike claimed his plan would ease mutual suspicion, but it would also prise open the secrecy of the Soviet military machine.
Open skies involve both the freedom to overfly each other and observe, photograph and observe what was happening, and second, an exchange of blueprints, as Eisenhower termed it, of the military programs on both sides. We broke up for tea shortly after that, and as we were standing there, Khrushchev came walking up to Eisenhower, sidling up in his way of walking, and said, "Nyet, nyet, nyet, you're simply trying to look into our bedrooms." And as we were riding back, Eisenhower said, "Now we know who's in charge of the Soviet delegation."
Later that year at the Moscow Air Show, the Soviets allowed the West to see their new jet bombers, codenamed Bison. Significantly, overhead flew 10 long-range Tu-95s, capable of delivering a nuclear bomb all the way to America.
For the Americans, seeing 10 planes capable of reaching the United States was a shock.
На территории Соединенных Штатов Америки, естественно, было шоком. До этого считалось, что
At that time,
баллистических ракет еще не было.
in the absence of ballistic missiles, they supposed that the Soviet Union didn't have any means of delivery to America.
США Советский Союз не имеет.
In response to fears of a bomber gap, Ike doubled the rate of B-52 bomber production. America needed to find out how much of a gap there really was.
So to find out how much of a gap there really was, we introduced the E-2 spy plane. This again, not Pittsfield. Edwin Lant is a Massachusetts guy. He found a Polaroid camera in Cambridge. Edward Lant was on one of Eisenhower's advisory groups, and he told President Eisenhower, a single mission in clear weather can photograph in revealing detail a strip of Russia 200 miles wide, 2,500 miles long, and produce 4,000 sharp pictures. So Eisenhower was intrigued, and he partnered Edwin Lant with Lockheed Martin's Skunk Works director, Kelly Johnson. And they did just that. They created the U-2 spy plane. And in just 18 months, they developed this airplane that flew almost twice as high as anything ever had. Carried a camera with a 3,600 foot roll of film. They had to be built in a specially built facility. Just a tremendous success. And this is, I think this picture was taken on the 4th flyover ever of Russia. This picture was taken by a pilot named Marty Knudsen, and he flew over Engels Airfield, and he photographed what turned out to be the entire Soviet fleet of Tu-95 bombers. This is a very exciting book here by Ben Rich, who ran Skunk Works after Kelly Johnson retired. And in this book, he describes that when these pictures of Engels Air Force Base were delivered, that Eisenhower and the CIA director, Rich Bissell, were poring over the photographs of Russia on the floor of the Oval Office, counting the bombers. So there were fewer than they thought. That's when we learned that the Soviets were actually flying the same, dozen planes in a circle at that air show film to make it look like they had more. So when we learned there was not a bomber gap, we learned bombers were actually obsolete. We could reduce our investment in bombers and start investing more in missiles. Missiles were the weapon of the future. By the way, this book really helped me figure out how to tell this story, because it does a wonderful job in telling the history of Skunk Works through the lens of world events. So that's what I've tried to emulate here. So in 1955, there's something called the Killian Committee, and they recommended the creation of an intermediate range ballistic missile. This is, before that U-2 flyover, and there's a lot of risk here, right? So we're pursuing a lot of things in parallel and trying to figure out what investments are the right investments to make. So this missile here is called Jupiter. You recognize this star here. This is the Army star. This is a land-based missile being developed by the Army. And the Navy, led by a group called SSP, which is still together today, was asked to develop the Fleet Ballistic Missile. And their mission was to launch this Jupiter missile from the sea. So there's a gentleman here named Vice Admiral William Rayborn. He was the first director of SSP, which was formed in 1955. At the time, it was called the Navy Special Projects Office. I'm just going to call it SSP here. There are several names throughout the history of this portion of the Navy. So Rayborn took over the Navy's nuclear weapon program in 1954, which was actually the lowest priority in the Navy. That obviously changed in 2 years. So in Rayborn's obituary in the New York Times in 1990, there's a suggestion that taking over the Navy's nuclear program in 1954 was actually a demotion. There was an explosion on a ship he was commanding and 91 sailors died. Just a quote from the obit, quote, although Captain Rayborn was praised for his handling of the disaster, he was assigned to a program that ranked near the bottom of the Navy's priorities, developing an intercontinental missile for submarines. Then later on in the same obituary, spoiler alert, he delivers the weapon with Pittsfield's help. Quote, the weapon was hailed as an American triumph in the Cold War arms race and as a boon to the country's allies, whose acceptance of American nuclear missiles on their soil was a constant source of friction with the Soviet Union. So in 1954, it's the lowest priority in the Navy. U-2 spy plane happens. And in 1956, it's the highest priority in the DoD. And this is the letter that shows that. This is a letter from Admiral R. Lee Burke, who was the chief of naval operations at the time. You can see this was at one point, this letter here was top secret. I read this, Rayborn called this the magic piece of paper he kept in his pocket. Because if anybody stood in his way, he could pull this out and say, no, I have the highest priority program in the DoD. So just a quote from here, it says, in view of the fact that the president wants a report monthly on this program, I, of course, will want a weekly report. And like the president, I want it to be a progress report. If Rear Admiral Rayborn runs into any difficulty with which I can help, I will want to know about it at once, along with his recommended course of action. If more money is needed, we will get it. If he needs more people, those will be ordered in, and etc. This is the highest priority program in the Navy. This is called an OV1. This is an overview diagram that shows what's happening here. It's we have an underwater launch, which had never happened before. A first stage missile flight, a second stage missile flight, and then a separation and a re-entry body free fall. This is a ballistic missile. And it hits the bad guy 1,200 nautical miles away for the A1. This is the D5. You can find all these on the internet, of course. So with higher accuracy comes more complexity. But you can see it's generally the same diagram here, but we are much more accurate. This weapon was recently shown on an ABC News clip a couple months ago, part of our deterrent strategy, I'm sure. If you're interested, you can search Trident II on ABC News. I think it was in May or June. So in order to solve that problem, well, they have to design a bunch of things concurrently. They develop the submarine, the warhead, the guidance system, the navigation system, the fire control system, all these things concurrently. And so they had to develop their own development techniques. So they created something called envelopes, which would describe how these things, how each one of these subsystems interfaces. So to illustrate the concept of an envelope, they say if the missile is 20 feet tall, 60 inches, and weighs 15 tons, if you know that, well, now you can kind of design a submarine around it. And the missile people can go design their missile, and the submarine people can go design their submarine. So just to solve this problem, they had to develop this technique that had not been done before. They did that in the first quarter of 1957, and they still operate that way today. We still control our interfaces in the same way. This is what the org chart looked like in 1957, and of the Special Projects Office, now called SSP. And so what you see here is a group that does fire control and guidance. You can see this in SSP's website today. There's a group that does fire control and guidance. And this is us. This is on the org chart from 1957. This says guidance is MIT's industrial lab. This is Mr. Charles Draper. This is now Draper Labs. Charles Stark Draper was one of Time Magazine's People of the Year in 1961 for his work on the guidance systems that were in the space race. And he also designed the guidance systems that were in the submarine launch ballistic missile. This is GEOD. This is General Electric's Ordnance Division, working in the guidance system and the fire control system in 1957, which we still do today, and we will do to 2084. All right, so now let's take a glimpse back at the world and what's going on in 1957. Russia starts turning the screws. In August, they actually demonstrate an intercontinental ballistic missile, the R-7, with a nuclear warhead. They launch Sputnik on October 4th, and Sputnik 2 in November, with Laika, the dog, the first living being in space. Laika didn't live long. I think 4 orbits, and then they had a problem with the air conditioning unit, and the poor dog died. But this is a tremendous amount of pressure that Russia was applying. And the U.S. response was to accelerate Polaris, accelerate this submarine launched ballistic missile that's being partially designed in Pittsfield and still being worked on in Pittsfield. That's how important this is. So not only accelerate it, but I remember the special project, this mission became a thing in like December of 1955, and with a goal of having to deliver the initial capability in 1963. And they say, you got to do it in 1960. How can you deliver this capability in 1960? Incredible. Well, one way you can do it is by not designing a submarine. They cut a submarine in half. The USS George Washington was originally called the USS Scorpion. This is built by General Dynamics Electric Boat right down the street in Groton, Connecticut. And they actually cut the submarine in half in January of 1958. Just 2 months after the dog was put in space. They cut in half and they added a 130-foot section for missiles. You see all these cylinders in here? This is the missile section that they just added on to what was previously called the USS Scorpion and renamed the USS George Washington. And indeed, in 1960, we did it. An A1 variant, a 1,200 nautical range missile was launched July 20th, 1960, off the USS George Washington, off Cape Canaveral, Florida. And of course, a second missile was launched 2 hours and 53 minutes later to not only test the crew and the systems, but to prove to the Soviet Union that this is not a fluke. The button that you press to launch this missile out of the submarine, that goes to the fire control system. The fire control system basically makes sure that all the right doors are open and all the other right doors are closed, that the missile knows where it's going, that it's ready, and off it goes. And that is all that technology was invented in Pittsfield, Massachusetts, and is still being worked in Pittsfield, Massachusetts. And of course, as we already established, the guidance system that brings this thing to its target, Pittsfield, Massachusetts. So patrol begins on November 15th, 1960. The USS George Washington goes on operational patrol, and it's been on continuous patrol ever since, and ended the Cold War. Okay, so let's get out of this war stuff for a bit. We're going to talk about some other things that of course have happened in Pittsfield. So in 1953, Dan Fox invented Lexan plastics. You've probably seen Dan Fox Drive, right? Dan Fox Drive is what Bosquet is on. That's named for the inventor of Lexan. This is the flagship product of GE Plastics. Of course, Jack Welch started his career at GE Plastics after graduating from UMass Amherst. And he lived in Pittsfield on Brookside Drive until moving to Fairfield to be an executive and, of course, eventually CEO. And Lexan was so valuable that, when Sprague bought GE Plastics in 2007 for $11 billion, they were largely trying to get Lexan invented right here. This is a cool picture here. This is the Snow Express train from Grand Central Station. Grand Central Station still looks like this. And this Snow Express train ran from Grand Central to Pittsfield so people could ski at Bosquet. Bosquet ski area was the first ski area in the world with night skiing. And that's an invention here that happened because of this high density of engineering and manufacturing talent, which still exists today. And I think it's so cool now that Milltown Capital has bought Bosquet back in, I guess, 2020. They redid all the snowmaking. They've put in new lifts. And when they were redoing that snowmaking, they brought in the company who made the snow for the last 4 Winter Olympics to redo their snow system. So I think it's amazing that the company that made the snow for the Winter Olympics, probably the most important snow at a sporting event, also came to get the snowmaking working at Bosquet. It's incredible. So there's also Mass Mocha. Mass Mocha, of course, was previously Sprague Electric. This is Mass Mocha itself is incredibly innovative. I've been going there since I think 2000. And I always get a picture of my kids in Solowit and other places. Really incredible facility here. And MCLA has a really rich archive of Sprague history. The Sprague log was the company's newsletter that they started in 1938, and it continued until the company closed in 1985. And MCLA has almost every copy of it available on their website. Very, very interesting. So I'm going to talk a little bit about Sprague here as we get close to wrapping. So this is Frank Sprague. Now, Frank Sprague was born in 1857 in Milford, Connecticut. It was Frank's son Robert that founded Sprague Electric, but we'll get into that in a moment. So Frank is known as the father of electric traction. He invented the electric trolley, and he invented the elevator long before Elon Musk created Tesla. Frank Sprague grew up in North Adams. He went to Drury High School, and Frank collaborated with Thomas Edison and was an important enough collaborator to be mentioned in Paul Israel's biography of Edison, which is where I first heard of him. So Paul had a son in 1900 named Robert. Robert was born in New York City, and Robert was also a brilliant inventor. In 1926, Robert Sprague invented the tone control for radio and the paper capacitor, and he started Sprague Electric in Quincy, Massachusetts. So he spent 4 years running Sprague out of his home in Quincy with his wife Florence, who collected and fulfilled the orders, and Robert made all the capacitors. They added a third employee who operated a typewriter on their dining room table, according to this to the Sprague log. And they moved their business to North Adams in 1930, where Robert had spent much of his childhood. So their first facility was on Beaver Street. They had 400 employees, and in 1937 they moved to Brown Street. This is a nice picture here of Main Street. This is actually Main Street in North Adams in 1937, from the North Adams history website. Really, really vibrant, very, very cool. And here's an image of their. Let's see. This is their 1938. I think 1930. I think they were on Beaver Street. I'm sure somebody will correct me if I'm wrong there. This is the front page of the Sprague log. This newsletter is very, very interesting. If you had family who worked at Sprague, you might find stuff about them in these newsletters. Very, very interesting. So Sprague was an incredibly important company as well in the world. We've talked a bit about Sputnik, right? Which Soviet Union launched in 1957. Well, in 1958, another part of our response, going into the space race was Explorer, and Explorer had electronics on it that came from North Adams. And they also delivered electronics on, this is STS-1, this is the shuttle Columbia. Sprague delivered electronics to Columbia. Really, really incredible. So let's see. Yeah, so 1937, they were on Brown Street. In 1940, they had 1,300 employees, all in North Adams. So they made capacitors and other components for tank ignition systems, transceivers, radar, radio. They designed and built the variable timing proximity fuse for the Army and Navy bombs that were used in the Battle of the Bulge. They made the capacitors used to ignite the atom bomb in Nagasaki. Those were all made in North Adams. And by 1960, they were in 4 other countries, Japan. Let's see, it was Japan, Italy, Scotland, and France. Until they closed in 1985. Sprague's a fascinating company, and I'd like to learn more, which I'll do at the MCLA website. Okay, so now let's talk a bit about how we're also transforming the face of the Navy. I talk about this in the opening slide here, right? This was a submarine launched ballistic missile submarine that's been converted from launching Trident II missiles to launching Tomahawk cruise missiles. To combat the asymmetric threat, this is the littoral combat ship. These look very different from the Navy that existed just in the previous decade. So let's talk a bit about that. Let's see. I'm just using this slide to illustrate that in 1989, there were 592 ships in the Navy. Excuse me. Almost making it through the cold. So in 1989, the Navy had 592 ships. The last number I was aware of, I think it was 296. So less than 300 ships in 2021. They've set a plan to have 355 ships by 2049. So this is what the Navy looked like. Sorry, this is what the Navy looked like in the 90s. This is USS Wisconsin, which was built in 1940 and decommissioned in 1991. So in the 90s, the U.S. Navy was recognizing that its Cold War era cruisers and destroyers had been designed for open ocean warfare. Excuse me. I gotta get rid of this tickle. Thank you. So during the late 1990s, the Navy was recognizing that its Cold War era cruisers and destroyers had been designed for open ocean warfare, and they'd be vulnerable in shallow coastal waters. Also, when Saddam Hussein invaded Kuwait, and we pushed him out in 2 weeks, realized nobody would ever stand toe to toe with our army again. It was the asymmetric threat that we really had to start preparing ourselves for. And of course, in October of 2000, the U.S. coal was bombed in the Sea of Yemen, where it stopped for refueling. They thought they were being guided into port by a local tender that was actually, unfortunately, manned by Al Qaeda. So they triggered a bomb, blew a 40-foot hole in the hull of a $1.5 billion ship, and killed 31 sailors. So this is really the asymmetric threat. It's different than the toe-to-toe threat that the Navy was actually built for. So enter the littoral combat ship. So this looks completely different than the Navy in the 1940s, which was still around in the 1980s. Continuing a bit on the theme of engineering talent and business acumen, by the time the littoral combat ship had come around, this business, which was William Stanley, and then bought by General Electric, then bought by Martin Marietta, and merged with Lockheed Martin, was then bought by General Dynamics. And so there was a team who went around to meet their new General Dynamics brethren to look for problems to solve. Say, hey, this is what we do here. We're great engineers. We're great at building stuff, and we're great at business. How can we help you, General Dynamics? And so they met a lot of people. They met people at Bath Iron Works, where they make the DDG-51, that ship that I just showed. That was this ship here is made by Bath Iron Works. They met people at Electric Boat who make the submarines, and we found this program called Littoral Combat Ship. And this ship is transforming the face of the Navy. Like, this looks completely different. This is designed for the asymmetric threat. This is designed to find mines, and this is designed to be rapidly deployable for the threats that we don't know about, not the toe-to-toe threat. It's got this helo deck here, which is about 2.5 NBA basketball courts. It's absolutely massive. And here it is sailing next to the EPF. In Pittsfield, we designed the networks, the armament systems, the navigation systems. I worked on both of these ships. I worked on LCS for, I think, less than 3 years. I worked on EPF for about 7 years, I think. I think I rode the first 2 or maybe 3 ships. out of our partner shipyard in Mobile, Alabama. So all this work has happened in Pittsfield, Massachusetts. And I hope this little timeline here helped give you an appreciation for, I guess, what Ben said. Innovation at the Berkshires did not start in when the Berkshire Innovation Center opened in February 2020. I don't even think it started in 1886 when William Stanley perfected the power transformer. There's a lot more stories to be told here, but the story I just told here is in 1886, William Stanley perfected the power transformer, created a business with an incredibly successful business and incredibly high density of engineering and manufacturing talent. So in 1940, Pittsfield's rare density of engineering talent was asked to turn to the World War II effort with the building of the Mark 37 gun fire control system. During the Cold War, E-2 spy plane revealed that there was not a bomber gap and the nation should invest in the Polaris, which has been in continuous deployment since 1960 and will be till 2084. And since then, we've been transforming the face of the Navy. Okay, any questions?
Okay, thank you, Evan. Thank you so much. This was fascinating, and I'm going to, we have a couple of questions, but I hope people will start putting additional questions in now. Evan's talk was very fast-paced, and so I'm sure there are going to be a lot more questions in the next couple of minutes. But we have a question here from Mark Rosenman. And his question is, what other companies are here in Pittsfield that help support the ecosystem that General Dynamics is part of?
That's an excellent question. I guess, well, I'll say this. There's a tremendous amount of plastics work that still happens here. There's a lot of mold and tool manufacturers around, and those are all there to be super agile and solve problems that GE couldn't turn around fast enough, right? Big companies are slow and they have momentum, and there's a lot of value that big companies bring. But wherever there are big companies, you see these small companies who are there to be faster and more agile to solve problems that the big companies cannot, right? And so there's a lot of companies around, plastics companies who make tooling and molds and stuff for plastics, and those all come out of that. There's also Lightning Technologies, which is now NTS. And I know that they came out of the GE transformer business. Transformers are connected to power lines, and power lines are subject to electrical storms. And so that was called Lightning Technologies 20 years ago. They were bought by NTS, I don't know, 10 or 15 years ago, and that all came out of GE. There's also EPRI in Lenox, who's also studying power they are, yeah, I think they do some work in lightning. They do work in power transmission and study power grid technology, that sort of stuff. And a lot of that all came out of General Electric. In fact, I think they had like a long line of General Electric engineers who ran that facility. I know our recent general manager, Carlos Affinella, I know that his father ran that facility for a long time, and he was recruited from Italy to come work on that. What else am I aware of? I guess those are just some things that I'm aware of anyhow.
Okay, excellent. I'm a retired college professor, so I'm always thinking about the educational angle. So how do you see the educational institutions, both in Western Mass, so UMass, and also in the Albany area, impacting the work that you do?
Well, we certainly recruit from those schools. We've got, when I started in 2003, I remember I had so I went to UMass Amherst, and I had a UMass Amherst alumni guide, and we were one of the top recruiters of UMass Amherst engineering talent. And I think we were about 700 people. We're 1,600 now in Pittsfield at General Dynamics. It's a huge growth in 20 years, huge growth. And I think when I started, I think there were something like 85 UMass alumni there. It was like 10% of more than 10% of the whole workforce. We also partner with BCC quite a bit. We've partnered with MCLA. We've hired a lot of their students. We've hired math majors from Williams College. We've hired software engineers from UAlbany, and all kinds of engineers from RPI in Troy, and from Clarkson and Potsdam. Yeah, it's, I think being close to that kind of tech schools is incredibly important. UConn.
Okay, thank you. We have a question here. Says, thank you for the historical overview. And how has the history impacted the current focus and the priority sectors today at General Dynamics?
I'm not sure I know what a priority sector is. Can you help me understand that a little bit better?
I think okay, and Fatima Bashin, who put this question in, is a UMass O2 graduate. I think she must be talking about are the fire systems, the navigation systems, what are the kinds of systems that are still being developed here?
Oh, okay. Yeah. Thank you. Of course. Yes. Fire control and guidance. Absolutely. We also, we have there. I think Brenda Burdick is going to talk about General Dynamics. Ben, is that next week or in 2 weeks from now? I think what she'll probably describe is that we are the headquarters of something called Maritime and Strategic Systems, and Maritime and Strategic Systems has 4 business areas: undersea, strategic deterrence, surface, which is littoral combat ship and EPF, and then airborne, which is mostly done in elsewhere. And so, we have 1,600 employees. I think let's see, 1,000 of them are in engineering, about 250 are in manufacturing, and so we're focused in those 4 business areas.
Okay, thank you. That's very helpful. We often hear about spin-offs from the defense industry to other industries. And so Jim Rosenstein is asking if there are any spin-offs, especially related to environmental issues, energy and power transmission.
I think that's what EPRI is working on in Lennox. There's also EMA, which is housed at
Yes,
at the BIC, right?
Mm-hmm.
So EMA, like they're working on lightning protection for the F-35 and for protecting satellites before they go into space, and I think things like that. That's all related. I'm personally unaware of people working on environmental things. I'm personally unaware of that.
Okay, thank you. I have another question, and that is with the transformation of GE and the reduction of the number of systems that they're working on, and business areas, how does that impact something like the work that you're doing?
Well, we're not impacted by General Electric anymore, right?
Okay.
We're at GE for 90 years, so GE had, how many businesses were here? Plastics, transformer, ordnance. I'm unaware of any others, right? So transformers was high technology for 60 years or so, right? And then it became commoditized. So GE has sold off that transformer business. They sold it to Westinghouse, and Westinghouse sold it to a Chinese company. You're surrounded by transformers. You have so many transformers in your house, you don't even know it. And it's commodities. It's all just coming from China. Saudi Arabia Basic Industries Corporation, SABIC, right? They recognize that oil is limited, and they need to diversify. And plastics, a lot of plastics come from petroleum, and so SABIC bought it. Saudi Arabia Basic Industries Corporation bought GE Plastics, I think, to diversify their country's economy. I think that's kind of how that happened, right? And then GE got out of defense. They don't do any defense anymore. I guess I'm sure they sell aircraft engines, but we're not really affected by GE's downfall at all.
Okay.
I certainly studied it. I interned at General Electric in, I think, 2000, in Jack Welch's last couple of years. I was there for his swan song, and I've studied it quite closely because, I learned so much there, and I didn't want the lessons that I learned to be sullied by the fact that the company then failed. So there's a really nice book called Lights Out that came out, I think 2 summers ago, which it's the best book that I know of that describes the downfall of GE. But we're not affected by it.
Okay, thank you.
Okay.
Ben has a question, I think.
Yeah, thanks, Catherine, and Evan. Can't thank you enough for the presentation. Really enjoyed it. I'm wondering about how COVID impacted the business, particularly around supply chains and the manufacturing, and whether the sort of refocus on supply chains and the importance of supply chains has opened up opportunities for smaller manufacturers to supply into GD, or sort of highlighted the need for some of that, or how it's impacted the business in general.
That's an excellent question, Ben. I'm not sure I have the right answer. I'm sure that it's opened up opportunities, and I know the BIC just hosted finally the delayed supplier show that you and I were working on way back in 2020. I know that just happened, but I wasn't there for it. I'd say that one of the things that we saw in COVID, we saw just how resilient we were, as a workforce, and how resilient we were as a business. The folks who do manufacturing, right? They have to be in the business. They have to be in the plant to build stuff, and they figured it out. They figured out how to space themselves and be safe and continuous. They got masks. We were buying masks at CVS and Walgreens and stuff to keep all that going. I'm going to keep everybody safe, and we've not had a single transmission occur in the office, which is incredible. 2.5 years into this, we have the same, or we have similar supply chain issues as as the rest of the world. I got a friend of mine who is a tremendous cyclist, and his big worry is that his big personal worry for his hobby is that he's going to break his bike and he's not going to be able to get a new one. And he's got a nice bike, and he also doesn't want to spend. So his conundrum is, do I give them $10,000 today for a new bicycle that I'm not going to see for 18 months, right? That, 3 years ago you'd have walked away with in a week, and so I don't think anybody's immune to that. And I'd be interested to see what Brenda has actually in a couple of weeks on it. It's not the space that I'm working in right now.
Okay, thank you. One last question here. And I think we're getting pretty close to the end of our time. So for our participants, if you have more questions, please put them in the chat. But Evan, if besides the work that the BIC is doing now, what do you think would be 2 or 3 important points of growth here in the Berkshires that could both support General Dynamics, but create a more vibrant tech ecosystem here in the Berkshires?
Well, and as mentioned earlier in the chat, there sure is a lot of money coming out now for green power, right? And me personally, it's just Evan Hickok speaking. It appears that all the oil is in the hands of scoundrels. Putin's got a lot of oil. MBS has a lot of oil, and we are succumb to them. The price of energy is really high in England. I'm paying $8 a gallon for gasoline. So I bought a Tesla. And my electric vehicle is going to save me thousands of dollars just on fuel from being here. The cost of energy is incredibly high. And we have to negotiate with tyrants to get it. When Putin shut off his oil tap, Biden went to MBS and said, we believe that you were responsible for killing Jamal Khashoggi, who worked at the Berkshire Eagle, and thank you for more oil, right, to lower prices. Like, we can't live like this. I think that green energy is incredibly important for reducing the power of these tyrants who have this oil. And there's a lot of money being thrown at it, and that's great engineering right there. That is great engineering. And I think we've got a lot of land that we could put to good use there.
Sorry, unmuting myself. That is a great segue to what's going to be happening next week. Next week, we are going to be talking about green energy. And that is going to include wind power, solar power, and electric vehicles. So Evan has touched on 2 of those points in his answer. And I think that is a great way to end our evening and point us towards our next session. Evan, I can't thank you enough. Ever since I moved to the Berkshires almost 7 years ago, I have been blown away by the history, the business history, the manufacturing history, the tech history of this region. And your presentation really satisfied some of my curiosity. And we may have to tap into those people at MCLA about the history at Sprague. But again, thank you very much. Ben, do you want to say anything here as we wrap up?
No, thank you, Kate, and Evan. Thanks again. It was a pleasure.
Okay, so for people who are on tonight, please go to the OLLI website. It's in the chat to sign up for next week.
Great. Be well, everyone. Thank you.
Thank you, Evan.
Thank you all. This has been a real honor. I appreciate everybody's interest here today. I'll see you again.
Thanks.
Take care.
Bye-bye.